What is up? This is section 2.3, day number 2, the decomposition of functions. First we composed functions and now we're going to decompose them. So basically we're going to start out with one function and break it up into two. You could technically break it up into more than that, but we're just going to take it into two functions. And the big tip for today is to write out the order of operations that you would do when evaluating a function. The instructions might see something like this. Find f of g. So these are the two functions such that h is the composition of the two. You're starting with one, and at the very end, you should be able to say something like, aha, as the answer, f of x is this, and then g of x is this. And that's my answer. And find f and g in such a way that when you compose them like this, you get back to the original h. So let's decompose them, let's break them up. The tip is to write down the order of operations that you would evaluate. So let's say, just do some pre-work here on the side. So for example, pretend you just had like h of 2 that you had to evaluate. The first thing you would do is substitute for x, and then you would multiply by 2, and then you would subtract 3, and then you would raise it to the 5th power because everything else is inside parentheses. So what I'm going to do is we're just going to focus on these three orders of operations. And what we can do is we can group two of them together and then the other one over here. So this is going to be my g of x. Because, or let me explain why. Well, if h of x, I'm just rewriting the instructions down here. If h of x is going to equal f as a composition of g, then that means that f of g of x must be equal to h. So let's bring the first two functions in and make them g. What that would look like is we've got x, and then we multiply it by 2, and then we subtract 3. Same operations that we did here. And then the third one, we're going to make that f of x. And so whatever you get of g, then make sure you raise it to the 5th power. If you define f and g like this, then apparently when you check your answer, by the way, that is our answer. Maybe I'll just fill it in right here. F is x to the 5th, and g of x is going to be 2x minus 3. That's our answer. Let's check to make sure that it's correct. So check. If h is indeed h of x is equal to f of g of x, f composed of g of x, then that of course means that when you take the f function, you plug g of x all the way into it. And let's see. What is the g of x function? That's going to be 2x minus 3. And we're going to plug it into the f function. The f function is x to the 5th. So we'll take the input and just write it everywhere we see x. And yeah, this is in fact equal to h of x. Yay. So yep, the check works. The two functions compose this way, or decompose this way. Let's do that again over here with this function, this definition of h of x. Well, order of operations. If we had x, then we would first add 3, and then raise it to the 3rd power, and then take the reciprocal, or put it in a fraction, 1 over x. We will consider these two functions to be g of x, and we'll consider this one to be f of x. That's the most complicated one. We'll just leave it all by itself. So what would it look like to first add 3 and then cube it? Well, it's this part right here in the bottom. it would be x plus 3 to the third power. And then we'll use the reciprocal function here. So this is our answer. Now let's check it. This is our answer. Let's check to make sure that it's true. I'm going to copy this down here. Check. Is h of x really the composition of f in g of x? Let's find out. That's really f of g of x. And let's figure out what g of x is. G of x, we defined it as x plus 3 cubed. And then the f function, 1 over x plus 3 cubed. Yep, that is exactly equal to h of x, so yes, it works. By the way, this is a good time for me to mention that the audio check for today is, guess what? The capital of Ohio is, it's Columbus. Have you ever driven through Columbus? I believe I flew out of Columbus once, but I've never stayed there. I hear it's a beautiful city, so tell me about it in class. Columbus is the capital of Ohio. So here we have h of x, and PEMDAS is going to be a little tricky on this because there are two places where you can put in x, a value of x. If you were substituting, if you were just, for example, trying to find out what h of 3 is, you could plug 3 in to do two different places for x, and then you would cube them. And it didn't really matter which order you would do, and then you would subtract 1 from one of them, and then you would add 1 to the other. And then you would combine them together excuse me, into a fraction and simplify. And you could either simplify the fraction or turn it into a decimal or whatever you wanted to do. So what I'm going to do is I'm going to consider this to be my first function. That'll be g of x. And we'll just call that the cube function. And then all of this will be my f of x, the second part of it. So that'll have to be the fraction x minus 1 and over x plus 1. But I'm pretty sure that if we check, so this is our answer, and let's check our answer. Is h of x actually the composition of f in g of x when it's defined like that? Well, that's just f of g of x, and writing g out, that's just x cubed. So f of x cubed, what would that be? That would have to equal whatever the input is minus 1, whatever the input is plus 1. I'm getting that from the definition of f of x. But the input is here, x cubed. So yes, that is in fact equal to h of x. Yay, the check works. That's it for today. It's a short lesson, short video, so go ahead and start the assignment 2C2. What I'd like you to do is copy down the problem list and do the first problem, and then I will see you in class. Bring your questions, bring your notes, and we'll have a great time.